Om Shri Sai Ram. With humility and love, we offer ourselves at Swami's lotus feet. Respected elders and dear brothers, welcome to this year's National Science Day celebrations, NSD 2022. As part of NSD 2022 celebrations, we have a popular science talk scheduled for this moral class session by an eminent speaker, Dr. Anuj Mubayi. To take the proceedings further and for introducing the speaker for this session, I request Dr. Saisham Sharma to take over the dais. Thank you. Over to Dr. Saisham Sharma.
Sairam, everyone. A good morning, and I welcome Dr. Anuj. Sir, it is good to see you again, and it's my honor to introduce you to today's gathering. So, for the rest of us who are getting to hear Dr. Anuj for the first time, here is a very brief introduction of him. Dr. Anuj Mubayi is currently a research scientist and the lead at the Infectious Disease Forecasting Group at the Public Health Company, and he is also a distinguished IBA Fellow at the Center for Collaborative Studies in Mathematical Biology, Illinois State University. He is a former faculty of the Arizona State University, where he was the director of the Presidential Award-winning Mathematical Theoretical Biology Institute. Dr. Anuj is an applied and computational mathematical scientist with more than 10 years of experience in disease modeling and health decision analysis. His research is driven by quantitative and qualitative modeling of problems of interest to the public health or social science communities. His recent research interests include the development of new cost-effective tools for ameliorating the impact of infectious diseases while increasing the understanding of mechanisms that drive their prevalence and mitigating morbidity-related consequences. Today, Dr. Anuj has decided to speak to us about seeing into the future through lens of modeling of complex systems, which will talk about capacity building, science communication, and entrepreneurship. With these few words, I now invite Dr. Anuj to address the gathering and share his experience, thoughts, and wisdom with all of us. Dr. Anuj.
Um, Thank you very much, Dr. Sharma, and thank you to Dr. Vamsi Dasu and others who are behind the scenes of this National Science Day. It's pleasure, honor to be part of it and to talk with you, all of you here. Well, I was thinking about what would be the best topic for us to discuss today, and well, there are lots of things I have been doing in the past. I have like almost 2 decades of experience. It has been always an honor to work with Satsai Institute of Higher Learning, Dr. Vamsi Dasu and others we have organized different events and activities on campus and in general in the nation. So, well, as before I go further, let me give some of my career path. Actually, it will help some of you to see how I am trained, what I am doing right now, and what I've been thinking about doing in the future. So my career path has been a random walk. In mathematics, this is a very important term used for describing the path of something which has a lot of stochasticity in it. So I started with Indian Institute of Technology in India. I did a pure mathematics masters and then followed by PhD at Arizona State University in US. And then I did a few postdocs, including one in Cleveland Clinic, which is one of the US largest hospital. Actually, it's a topmost hospital along with Mayo Clinic in US. It has a chain of hospitals, by the way, and I was part of an infectious disease modeling group in this hospital group. And then I was part of a global health team at Case Western Reserve University. This was my second postdoc at the after infectious disease. Followed by, I was a faculty at Arizona State University in a School of Human Evolution and Social Change, where we were talking about how evolutions of culture evolves or how people change their behavior over generations. And remember, my training has been in mathematics, and I've transitioned from infectious disease to global health to human evolution, for example. And then I moved to an organization called as Precisionheor, which is in health economics, followed by um, I'm a distinguished fellow at Illinois State University right now, Center for Collaborative Studies in Mathematical Biology. I'm also a senior fellow at Kalam Institute of Health Technology, which is in Visakhapatnam, and it's Make in India. It comes under the Make in India for Government of India. And I'm currently also adjunct faculty at Department of Mathematics and Computer Science at CSAT Science Institute of Higher Learning. And then followed by, so currently I'm also attached to the public health company where I'm leading an infectious disease forecasting team. So last four appointment has been simultaneous. Um, and but the reason I wanted to show this thing is, the trajectory path has been guided by opportunities which are not constrained in the field that I'm trained in. For example, I'm trained in applied mathematics and infectious disease modeling. But over a period of time, I have worked on health economics, global health, and of course, mathematical biology. So this is important to know because real life problems are not discipline dependent. It is very, very wide. And I mean, the tools and techniques that we learn in the degree programs needs to be wide spectrum in order to address the future problems. Okay, well, can I request some of you to let me see if I can quickly do one thing. Just hold on 1 second. I have to stop this thing to share this. I want to do a survey with all of you. Can you all fill out? Okay, let me see where is the chat. Can you all fill out this survey, please?
Yes, sir. Yes, sir.
I'm asking all the audience, please do fill out that survey. It will be helpful to me. And there are two questions in the survey that one address I have just messaged you in the chat message. Look in the chat message. And the second one also I've sent you. So you may have got both of them. So okay, now I will share my screen back and want to get some feedback from all of you. Okay. What is the one negative impact that COVID pandemic, and as you are guys are entering it, it is coming on the screen and showing to us what each one of us thinks are potential. I mean, everyone's life has been very different and it has been quite a negative impact in each one. And people see it in a very different way from person to person. So as you guys are filling, this is saying casualties, of course, education, yeah, very good. There has been major educational aspects, psychological aspects, fantastic. Employment opportunities, wonderful. Families, isolations, attention. What else we have? Yeah, remote working, right? That's true. Mental health, very nice. Financial aspects, fantastic. So I think I will now go back to the, so these are the issues that are negative impact. And this gives us an idea about what would be the future problems, right? This tells you how do we address the future problems moving forward. This is all of us. I mean, we never get a chance to sit together and talk, discuss about these things, but this um, poll or this survey has helped us to see the general public understanding about negative impact. Okay. And then can you also please use the second link and enter the positive impact now? This is a positive impact. Okay, consciousness, advancement in the technology. Okay, very nice. Family. Okay, you have more time for the family. Pollutions, reduction in pollution. Fantastic idea. Please continue to add your ideas to this survey. Okay, opportunities. Okay, you may have, some people may have got more opportunities due to the lockdown, due to the COVID pandemic in general, right? Okay, improvement in certain things. Okay, very nice. Reforms, yes, very nice. Reforms. We have made huge understanding of what is our problem. Just realization of what is our problem, is very important thing. If we don't realize what is our problems, we will not be able to rectify it, right? So reforms related to realizations, that is very important. Okay, so I think I will move on now. This gives us an understanding on what we think as a negative impact and what we think about positive impact. And in today's talk, I will talk about some of these things which I have seen it in my personal life. So example of challenges highlighted during COVID has been lack of consistent definition in epidemiological knowledge. For example, we don't know which is the case and which is the asymptomatic case, which is the symptomatic case. It is very, very difficult in the medical fields to identify what the case is. I mean, someone having flu symptoms, can you call it as a case of COVID? This has been a medical related issues and has been a great challenge on a day-to-day basis. So if you do not understand which are the cases, you cannot do any interventions. And this is a primary things to another thing is discrepancy between data. Discrepancy between data from patient level clinical insights to population level efforts. There has not been a link between, I mean, hospitals are collecting hospital clinical data, but how you relate to the public health policy related aspects. This has been a lot of mismatch here. This is a major issues that we are realizing in lack of third point, lack of adequate understandings and inclusion of individual behavior and social influences. How these lockdown are impacting behavior and social influences, how the policy decision making aspects, how is the disease itself changing the behavior aspects of the population. We don't know that thing. These are the major changes that are happening, which will have a long-term implications to us. Okay. Little flexibility of including new evidence in preparedness efforts. New evidence are coming very rapidly. The knowledge of being during COVID time has been exponentially grown in multiple dimensions. We don't know how to handle that knowledge, that new information. Another thing that we have been realizing is translating scientific findings quickly in a digestible manner. People are not understanding science, results of the science very well, right? And so if people are not understanding, then how can a government can make a policy making, right? Government is made up of people who are non-technical, some of them, right? So this is very, very key. These are what I see as made the combination immediate challenges that we have seen it in the problem. I want to give a very, very simple examples of freedom of mode of transportation. So, how we used to travel 100 years ago, or maybe 150 years ago. 1886, this was the first world car developed by Benz in Germany. It was horseless carriage, right? And that was the definition. Only very few selected elite people used to have it. Not everyone. Only few people who are very rich used to have it at that time. And that was the definition of car. um, family needing car for transportations, driver's license. These were the 20th century aspects that came into existence, but this is transformed in 21st century. The definition of freedom has now changing. What is it changing to? Because we don't have the space, so it is less space. This is the picture that you are seeing is a shared car that is being used in European countries, where they transport people from their houses to the bus stop or train stop. And these are for short distance buses. These are not having any driver. This is run on electric. um, it charges by solar system, so it's a new way of freedom of movement. Now people do not have a space to park the car, so they are using these shared services in 21st century. Moving forward, the future transportation will look like not only space, but will be issue, but the wisely using of a space would be very, very important. For example, this is a multi-purpose utility where it is used as a cargo in the night and in the passenger shuttle in the day. So the top portion becomes a cargo or becomes like a seating like in a bus. So it is reducing space, but also reducing the space in a wisely fashion. More people taking less resources, by the way. This is a future of transportation will look like. Okay, so things have changed quite drastically over a period of time and changing future in what we define it as a freedom of transportation. Okay. Now, is that what we are doing in our methodologies, in our understanding about diseases, for example? So there are evolution of techniques have also happened over last century or so. Earlier, we used to use simple differential deterministic equations in early 20th century using calculus ideas to track understanding about diseases and so on and so forth, even social problems. In later 20th century, we started to understand stochasticity more thoroughly. So we incorporated this stochastic methods into it. That was later 20th century. The 21st century is seeing what we are calling it as a multi-agent system, where you are tracking individuals and not the populations, each individual behavior that you are tracking, and you are modeling it. Well, in future work, what we are developing and what we are realized it from the COVID-19 problems, that we need to focus on multi-resolution modeling approaches. What does that mean? All these top three approaches that people have developed in methods, techniques based, are not taking into account behavior issues, social behavior, which we realize very important in the COVID times. Whether it is a healthcare system, whether it is an infection spread in the population, whether it is social issues, behavior aspect changes many things in the population, and we are not been capturing in the top layer of the methods and techniques. Also, we are realizing, and that is important in the multi-resolution modeling framework of future look like, is multi-scale aspects. How do you connect informations which are inside the body? Let's say if you take a medicine of some sort, it affects your cells and you change your behavior due to being now better in health, to maybe 10 years down the line, how do you earn your income, for examples? So it is from the inside the cells, now you are talking about different scales to population level, or over time, 20 years later or 30 years later, or from one country to another country, for example, or globally, right? The problems are not anymore local problems. So multi-scale issues have been big issues, and the data associated with it is a big issues that we are realizing for the 21st century future problem. Ensembles, collection of things. It's not like one thing should work all the time. We should have a collection of basket of things to explain some new problems that comes to the society. That is what, and that is a word we use at ensembles. It's a beautiful example from climate modeling. In climate modeling, there's no single model that is used to forecast or predict the climates. There are a collection of many models that are used for it. So this is what has been now realized more often due to COVID pandemic, that these are key features that we need to have in techniques. And the same way as the car has evolved, our technique should be evolving like this. Well, there has to be a new ways of thinking of future problems also. So I think first thing is I want to describe some new generation of scientists also. I think, of course, you guys are meeting lots of faculty, lots of research scientists on a daily basis, but I want to highlight few peoples who I personally have been interacted and have been amazing new generation of scientists. So for example, the first one is Dr. Carl Bartzen. He is a theoretical and evolutionary biology professor at University of Washington. What he has been doing for the last decade is he's identifying the low quality scientific research versus high. How do you identify that thing? How do you describe low quality versus high quality? So he has been his research has been focusing on that misinformation. How is this misinformation in some low quality work versus high quality, whether it is scientific article, whether it is news articles? How do you find that thing? Right. So that is what he has been. He's an evolutionary biology professor, but he's talking about misinformation, right? Okay. In 2007, actually, he introduced the term called as eigenfactor. I don't know, many of you might be aware of it. It was a metric used for general ranking. There is no metrics. Impact factor is one of the metric, but is that a right metric, first of all? So he introduced this eigenfactor, and for him, for this piece, he got an innovator award also a long time back. So disinformation and misinformation, and he has been very vocal in the media on things about which is common people are not talking before pre-COVID, for example. The second person I want to make you guys aware of is Dr. Simon Levin. He's a distinguished professor of ecology and evolutionary biology, also at Princeton University. He's my collaborator as well. But he was a faculty at Cornell University before it, and he was a faculty of biometric department. Biometric is like a biostatistics department, kind of. Now he's a professor in ecology and evolutionary biology, and he is a fellow of number of well-reputable science organizations, and he's award-winning of very famous award, MacArthur Award, a Kubo Award, and so on and so forth. Mentored more than 100 graduate student postdoctoral fellows. What he has been doing in his research lab is amazing way maintaining network of interdisciplinary scientists. His scientists in his labs are not coming from ecology or not coming from mathematics, they're coming from social science, coming from very different areas. And he's training them to make the scientist of new generation that would need, I mean, problems should not be discipline dependent, first of all, right? So new generation of scientists should have those skills of interdisciplinarity. Third person that I want to introduce you guys to is Dr. Nassim Taleb. He's a retired distinguished professor of risk engineering at New York University. He's a fellow of math finance. He built many models. He studied finance market quite a lot. He has famous book, New York best-selling books in his name on uncertainty quantification, Fooled by Randomness, Black Swan Events. It's a very famous books, by the way. And he is very well known. Actually, Government of India also consult with him for many things, from bringing entrepreneurship in the country, innovations into it. We are not training these new generation of students in our classroom of entrepreneurship, right? It's not the cup of only management students. It is also now needed in a mathematics department, in a statistics department, in computer science department, in any department, in fact, because entrepreneurship can lead to new innovations in any fields, and it is not field dependent, by the way. So that's what he kind of shares his views on, and Indian government does consulting with him on various issues like this. The last person in this slide I want to introduce is Sonam Wangchuk. He is a founding director of Sikmol. You may have heard about him. He has been at Kaun Banega Crorepati, and he has been in multiple shows. Amazing person. If you read his articles, you will realize what type of amazing work he has done in education and training. He has established an institute called as Himalayan Institute of Alternatives. What is this institute is doing is teaching. Remember, he is from Ladakh, by the way, and Ladakh, the education system resources are very limited. It's very difficult terrain to reach to that level. So it's very, very difficult for them to have a very good educational system. So what he has done is that developed a system with the resources present there in such a way that is non-traditional. That is not the way traditionally education people have been doing for last many decades. For example, in he has been using this techniques of um, learning by research. For example, you build things and you learn concept through that, rather than and those things that the students are building are useful for the local community. Okay, so it's very important. You should read something about it. He has been winner of recipient of many different distinguished awards like Magsaysay Award. He has been a Heroes Award of CNN, very famous Times Man of the Year by the Week magazine. So he has been very famous in this regard. And these four scientists, for example, I see them. They are in different areas, but they have tremendously making an impact in a mass scale in generating a new generation of scientists, and keeping in mind the future look like, and not going in a traditional way as the education system has been, not changing as much as these scientists are promoting, for example. Now, examples I want to talk about is what are the future challenges there? I mean, the COVID has made us aware of some of those things, but are we truly know these problems? We know these peoples are helping us to understand these things. So in 2015, WHO came out with the sustainable goals. There were like 17 sustainable goals. Now, they were designed in 2015. It was the first ever agenda by the whole world ever have taken. Okay, these are basic problem. No poverty. I mean, many of the developed nations um, earlier were less caring about it, but now WHO has come out, so they have involved developed countries, private partnership, many of those things. These are the issues of moving forward, new challenges. How do we address these issues? That's a different issue. But these are interdisciplinaries. These are use the cutting edge methods of the day to day if you want to address these issues there. Now, this started with a very good note in 2015, but 2019, where COVID made a huge impact on these things. It has stopped the progress in these directions. And therefore, we have to come back to these goals. These are very basic consistency. One thing in the US people are realizing is the problem is not local. That's very important realization. The problem is not local. For example, COVID started in Asia and then spread whole throughout the world. And this is not about only infectious disease. This is in fact ideology, social issues. There could be many sustainability problems, pollution problems. It could be at a multiple scales. This is the case. Now, now I want to also highlight a different angle here, future of medicine and medical technology. The reason I'm highlighting this point is because that has been my area. But I also want you to realize this fact that medicine and medical technology companies have not been the same anymore. Okay, so the companies have changed. For example, Google and Apple's are now medical companies. How many of us knows that? Well, Google, all these big five, we call it, big fives are Apple, Google, Microsoft, and a couple more. They are also becoming a health technology companies. They are now medical device companies. For example, Google has a medical unit called as Worley, right? So they are doing work in research and discovery, but clinical development, they are doing in supply chain of clinical products or medical products. They are launching the commercials of medical products in the market. How do you launch it in a better way? And then monitoring the health of the people. So they are now a medical company rather than IT company as such, I would call it. Okay. Now, state of art in cancer surveillance. Cancer, the top three diseases that pre-COVID were HIV, tuberculosis, and cancer. They were called as the big three diseases. Now, cancer surveillance and detection has seen a tremendous growth in their intervention, and I think COVID has led to that understanding that we have to quickly make scared way in growth in this area. For example, this test called as Galeria has come to the market, which is now a blood test, very convenient blood test, but it detects 50 different types of cancers now. So it's amazing tool that is coming. But remember, telling people in advance, early surveillance, early diagnosis, it has a cost associated with it. The cost is anxiety, stress in the patients. How do we deal with that thing? Those are the future problems, right? Think about that. If a person is now knowing very early on about their cancer status, they're causing lots of issues on a day-to-day basis in the mind of that patient, basically, or a family that is taking care of this thing. So those issues are also, it's not only development and new technology that is always good. There's a cost associated with it. And those are the things are the future problems, for example. CAR T cell therapies, and that has been used for treatment of cancer. That is basically they are training the immune cell to attack the cancer cells. This has never been there as a interventions in the cancer patients. This is a new technology. How is this technology will work? What is the impact of it? What is the cost associated on a common person? These are all the new problems, new challenges that we have to. By the way, HIV, tuberculosis, and cancer are the top three diseases. HIV has become more as a chronic disease anymore, not a deadly disease. Cancer is also becoming a more chronic disease because the interventions, the diagnosis have become so good now, basically. We are also realizing the power of data, and that data not in terms of regular healthcare data, but an alternative source of data such as social media. It is having lots of information that is useful for us, but we don't know how to filter out that information. But then there is also misinformation that is also available there, which is causing damage to our understanding and the progress in the future, for example. So these are the things are the future. But how do we handle this thing? How do we use, whether we are engineer, whether we are computer scientist, whether we are mathematician, whether we are biologist, how do we address these issues? Now you will say, what will biologists do for the social media? Well, biologists now are tracking signals for infection, for example, in the social media. If we write, for example, I'm having fever right now, they are using these signals to identify where are the cases, how many cases are there, right? So engineers are doing it for their own purpose. So there are different information that you can extract it, but you need a methods and tools to develop that things. Another aspects of in medical field has been rare diseases. It happens, there are many of the rare diseases, 7,000 rare diseases are there. 5% of the people, usually a population, suffer from it. It's very small proportion, but there are people who are suffering very significant. There is no treatment available for most rare diseases. One of the rare disease is spinal muscular atrophy. Um, its treatment is available. It's called Zolexma. It costs $2.1 million. One dose, one injection that is given to the child of a certain age group. If you do not give it to the child by that age group, the child will never have a strong muscles power and will have a very short life, for example, and very painful life also. So why is this cost so massive, right? How can we do our skill set that we have learned in our field to use it in to understand this future challenges, for example? Okay. Um, Another area in medicine that is coming forward is precision medicine. Well, in earlier days, so if you see the graph on the right hand side, there are two graphs with precision medicine and without precision medicine. In without precision medicine, earlier people used to get same benefits. So in clinical trials, they try a medicine, and if it is 70% over or 80%, depending on the treatment, then they accept that clinical that treatment. If it is 70%, 80% efficacy in the clinical trials. But precision medicine is something different. So those 70, remember in clinical trials, 70% are only efficacy. I mean, it's working on 70% people. But what happened to the 30% people, for example? So precision medicine takes into account each individual separately, but it needs a massive sets of data. It needs a data of my history of the background, like where did I live? What did I eat? What type of treatment did I do? All this information are needed to be more precise, and we call it as a precision medicine for a patient to give a specific treatment to the. Now doctors are doing that thing. Okay, but it requires massive handling of data sets, different scales of data sets, and we don't know how to handle these data sets. That's a very clear examples what we saw in COVID-19. We don't know how to handle different types of data, which is quickly changing and which is coming from different sources. Okay. So, and that's why we had a massive toll on due to COVID, massive number of casualty that happens due to COVID. Okay. So what are the challenges in addressing this 21st century future problems? Well, let's rewind ourselves to pre-COVID time, and I'm taking a health aspect because that's my area has been health data. How's the health data collected? So let's go to ourselves, rewind ourselves to pre-COVID. In pre-COVID, the health department data were very coming slowly. I mean, they write, some of the department use pen and paper right now, and to get the, they use old technology to collect the data, for examples in the remote areas, and even in urban areas that has been the case. If and many times they depend on humans going from patient to collect the community vigilance. They are doing quite to collect the data. Well, these big five uh, companies that we were, IT company that I was talking about, are are reducing these things, which were causing uncertainty in the public health data earlier. So what are the existing gaps in these data systems right now? Well, it is collected in a very not as a diverse community, but disparities are there. Some communities are heavily, the data is collected, and some community less data is collected. And that they are in disadvantage, and vulnerable community, they remain vulnerability. For example, there are communities in US which is called, which there are hardly any good fresh food grocery stores. So those communities are very poor. They cannot handle, they cannot buy expensive fresh foods. So there are not any stores there. So they will not get the fresh food. So they are in a disadvantage, for examples. And same thing happening in the data collection process, for example. So high disparity in data collection. Some of the laws, old laws, needs to be changed now because they are stopping the sharing of the data easily. Because you may not have a skills at home in your organization, but there might be someone else might use that might have the skills to use that data. So it is not easily shared, and they because of um, the data loss that are there. Much of the data are reported. I mean, in India, when Delta wave in last year was going on, there was no surveillance system of capturing how many casualties have happening in the local communities. How did we collected the data? Well, there was a news report and personal reports and news articles that were being used to make some data, right? So those are the gaps. How can we use these alternative sources to collect in more informative aspects of the society? So there's a need for consistent collecting of data. How can this? So let me give you an example. So for example, India has a massive railway system, right? Suppose each of the states were allowed to build the railroad with different width. They can choose the width of the railroad, whatever they want, each of the state. There will be a problem. There will be problem because the trains will not be able to move from one state to another because the railway tracks might have a different width, right? So in same way, we should not allow local health departments to change the general. We have to standardize the rule. National standards of data collection should be made that should be consistent in the state, in the local health system, in the all layers of the system, in the private laboratories, in the in other medical facilities, for example. That has not been the case. That has not been the case. Okay, there is public health, public private partnership is lacking. I mean, there's a lot in India, there's lots of private hospitals or health clinics. How is this data from a private being used in a case surveillance for the national report? It is happening more now, but there is still the gaps that we need to take. Also, we are putting so much funding right now on understanding COVID aspects and collecting data for it. But usually what our past experience have seen that as the COVID will going to subside, the funding will also keep decreasing and the data gathering process will become more weaker then. We need to make this thing as a regular inflow of the consistent flow of the data and maintenance of the health system. Now, when my students actually, I did, they talked about, well, I don't want to be in mathematics anymore. I want to go in data science field or big data field. Well, what is the big data? What is data science? Well, of course, big data, as the word say big, that means volume, velocity, and variety. Volume means large, maybe in terabyte and petabyte. It's a huge amount of data set. Velocity, that means it is coming very, very rapidly, every minute, every seconds. For example, in social media, we are inputting, population is feeding the tweets every second. So there's velocity of data and variety of data also. I mean, you could have satellite data to ecology data, the variety of data. So that means a big data. But what is data science? Well, most of the fields right now are doing data science fields. There is an overlap between big data and data science, but data science is a more general term. It covers multiple dimensions. It involves collection. In collection of the data, it involves cleaning of the data. It involves seeing the trend in the data. It involves projecting the data. It involves interpreting the information from it. So there's many layers of the data science data. So you don't have to know everything in order to get a data science field, or a data scientist, for example, in the job market. So any of the, and all these departments, all the departments have this thing. For example, in my field, mathematical modeling is a data science. Statistical inference is a data science. Computational simulation is a data science. Experimental design and data collection is also a data science. Each one of these is a data science. Okay, now it could have a different applications that I understand, but it is still a data science, all these things. So we don't have to change the field in order to go to the growing market of data science, which has become the trend nowadays. Okay, what is the skill set that I need today in the today's job markets? Well, we need to know storytelling, we need to know data visualization, we need to know programming experience, some statistics. How do we write a skill, oral presentations, entrepreneurship, working with the interdisciplinary. Many of these things we are naturally doing it, but we have to enhance it looking at the interdisciplinary aspects. That is a key here, basically. It has aggravated the, I think, the problem of COVID has aggravated has aggravated other issues. One of the issues is other neglected tropical disease. I work quite a lot in neglected tropical disease. These are neglected. That means before COVID, there were people, doctors were not interested in treating patients of this disease. Pharmaceutical industry were not making new medicines in that diseases. Why? Because there was no return, no economic returns from, because it was affecting the poor community around the globe. A 1 billion population affected, 1 in 6 approximately. So it's a major issues, but this has become more big problem because of resources being developed, diverted to COVID. I mean, I work in vector-borne disease dynamics. It has many layers of information that forms the problems. Okay, I'll go forward. Actually, I worked with lymphatic filariasis in Papua New Guinea. And lymphatic filariasis patient look like this in this picture, elephant-like legs. It is also called elephantitis. And this is basically massive legs or massive extremities, hands, due to lymphatic system not working properly. Well, I was working in Papua New Guinea. This is an island country in Pacific, and where this is having a high prevalence of it. So the question was, how do we eliminate that disease? So one of the projects that I was doing is the elimination of this disease from that location. How many rounds of treatment we should give so that we can eliminate it? There is no formula for it. So we were using mathematical models for understanding this thing. Also, I think my time is very close to the end, so I would quickly go it. There are some of the programs that I have been part of. I directed this program, which was called Mathematical Theoretical Biology Institute, which is on the left side. It has very unique features. It is called flipped hierarchy. And the flipped hierarchy was that the students come out with the research questions, and the faculties are helping students to grow their passion, the problems that they are interested in. It's not the faculty are giving the problems. It's a very challenge for the faculty, but we were doing that thing and developing the passion of the students, for example. This other one is called National Alliance for Doctors. These are very famous pioneer programs in the US. I'm part of this also, Math Alliance, it is called. It is making faculty from different institution as a mentor for students in a different university. So of course you are interacting with your own university faculty, but here the community of mentors are global, or I mean the faculty who are mentoring you for various things could be coming from different Europe, for example, or from India. Okay, so that's the feature of this has been, and it has promoting diversity in the community. I actually developed this course, which is very unique. It's not a, I invited faculty from public health department, it's a mathematical course, global health and modeling, but it uses new tools. It uses expert talks. It uses data handling, but then also it is using a technical knowledge of mathematics as well. So it has a mix of because the training that we need to change a little bit in order to do it. I have published papers which has been published in CNN. For example, the top right article is in CNN, where we talked about what is the problem challenges is the high school dropout rates. I mean, in certain parts of US, the high school dropout rates have been massive. So how do we understand that thing? What is the roles of parents? What is the roles of peers? What is the role of teachers in that, in decreasing or increasing dropout rates? So very good articles. It is a very old study now. It's published in 2017. I also talked about, I have been working on building sustained collaboration and diversity and building capacity in Latin America, in US, in South Asia, in India also. And therefore, I'm working with Dr. Vamsi Dasu also in many of the programs of your institution. But this is the SIAM article. SIAM is a Society for Industrial and Applied Mathematics, very largest organization of industrial and applied mathematics in the world. So I wrote an article on that. How do you build the capacity? How do you make this thing? One thing I'm realizing is the science communication. Our students are lacking in science communication. Well, how do you write text in the social media? For example, you have a published paper. How do you write this in Twitter has a specific length, for example? How do you write in first line, one line, the explanation, the gist of your research paper? It cannot be a title. It could be something that everyone can understand, right? Science communication has been key. Okay, so I've been working on new alternative data. How do you use a new alternative data? For example, we were using with a set of colleagues, how do you infection is spread during air travel, for example? So we are using CCTV cameras data, behavior data of why people go and spend more time in one corner or one place than other corner, for example, in the airport. We are using transportation data in that. So this is alternative data that we are using to understand infection spread, for examples. Okay. Our research was also Morgan Freeman, very well-known figure in Hollywood. He has a show called as Wormhole, and he interviewed us and he worked with us on one of our paper that was published long time back. It was on mass killings. There was shootings happens in many parts of the world where mass casualty happens. Why does that happens? Is there is a role of a media, because every time media highlight some events, is that impact the next event to occur in the future. So we talked about media contagion there, by the way. Well, we also link, medicine with the climatic factor. We use something called as catastrophic theories. For example, there are sickles. SCD stands for sickle cell disease patients. And now these patients have frequent strokes. They have frequent strokes. So anytime these kids have strokes, their day-to-day life get affected. Right. So how do you now what we wanted to study here is that when we give the treatment to these patients, it reduces the catastrophic events. It has an impact on the education. It has an impact on the income over lifespan. How do you connect these different scales? The treatment to the income in the lifetime. So that is the work that we are trying to work on, linking many skills. So what is I want to end here. I know it's very close to the end, but what are the skill set that are needing? I want to summarize that aspect that I talked about today. Well, the COVID pandemic has pinched us, has highlighted the gaps in the existence here, data inconsistency in the spillover effects from one problem to another problem. So what are the skill set that are needed? I mean, we have to train ourselves in 3 different skill set: learning, literacy, and life. Life is also important, although I did not mention today. Life is, for example, how to handle mental health, for example. These all aspects have to go hand in hand. So I will end here and with this food of thought. This graph is showing that people who we are training are not everyone going in academia. Some are going outside the academia, outside the science, outside, they are going in a research industry, they are going into private industry, some are going in academia. So we have to think in a broader sense in our training rather than focusing on a specific dimension. So with that, I will stop here. Thank you for having me, and happy to take any questions.
Thank you, sir. It was really a wonderful session, and also I would say more enriching, sir. So initially, I was also little, maybe I would say it would be more focused towards mathematical talk, but I'm happy that you have kept the talk more general, and I would say it's really enriching and food for thought, especially the points what you touched upon, like learning by research. That's a very interesting thoughts or what you said. And also the second one, when you said cost associated with technology, always we are happy and we boast about saying that we have invented a new technology which can be used in a wide variety places. But as soon as the patient comes to know, because this is something which was like I was also contemplating, as soon as he knows that he's at cancer stage 1, then he will be totally down, and the kind of suffering, maybe the financial or the emotional suffering, that also we have to measure. That's something really a wonderful thing to take upon. And precision medicine, though I have heard about it informally, but today it was much better. And for this also, I was teaching mathematical modeling course. The difference between big data and data science, the three words what you use, sir: volume, velocity, and variety. So this was really like the rules for big data, the thumbnails for big data, as you said, really struck me, sir. So over to the audience. If you have any questions or comments regarding this session, can you raise your hand or put in the chat box? You can unmute and then ask, sir. Yes, Paida Pranav, can you unmute your mic, brother, and ask, sir?
Yes, good morning, sir.
So maybe you can just tell you are studying which course, and then you can ask the question.
Yeah, currently I'm pursuing final semester of BSc Economics. So yeah, it was a wonderful talk. Like in fact, while you spoke about Nassim Nicholas Taleb's Black Swan and Fooled by Randomness, like I went through them, and even my presentation was based on Sonam Wangchuk's in my previous year. So it was a really wonderful thing. But sorry to be a bit pessimistic on the things. Like first thing which I want to ask is, currently we say A for Apple, B for blockchain, C for cybersecurity, and D for data. That's how Gen Z is going to learn. But let's say when we talk about data, when the tech for Amazon, Google, Facebook, and what other two, Microsoft, and one more is Apple. Yeah, these five are collecting data exponentially, majorly through the phones, right? So my phone knows me better than myself. That is the amount of data which my phone is collecting, and I'm not happy with it. Frankly, nobody would be happy with it, right? Like everything of you is, even we can see it in the Netflix documentary Social Dilemma. Like when everything is known, like see, there are pros and cons for every.
I think Mike.
Looks like we lost his connection, sir.
Well,
So
I
maybe
didn't,
you can give your views, sir.
well, I didn't understood his question. He was actually about to come to his question. Yeah, I mean, I think there are, what I said about big data and data science. One of the main other issue that one you pointed out, that big data means variety, velocity, and one more
Volume.
volume. Um, but what I want to stress the point on is the data science has some overlap with the big data, but data science is a separate field. And that doesn't have to be a volume, velocity, and variety. That could be something different that is dealing with the data that has not been used earlier and extracting information which is useful for us. For example, we use satellite data to figure it out, how many morgues are being used to find out how many cases of COVID has occurred during a certain time, right? So that has been used to count number of mortalities, for example. Satellite images, never thought before, right? It doesn't have to, satellite data doesn't have to be massive here, or doesn't have to be adaptive here, right? You could use it, but but this is also information that is, we use simple clinical information of how patients have been recovering in the hospitals, for examples. That is very, very important to give us the actual average time in which the time the patient lives in the hospital, for example. That's a simple data. You can do many distributions analysis on it, which is also a data science part. That is what I want to stress upon, that fact. So data science, people understand it is always data, big data, which is untrue statement. It could be a big data, but it is more to it. It is extracting the information from the data. Yeah, now you could not use hypothetical data. Yeah, you should be using the real aspects of the data to extract the information. So data driven aspect should be a concern.
Yes,
But
yeah. So we have one more question from Dr. Shrikant Khanna.
Sure.
Dr. Shrikant Khanna, can you unmute your mic and pose your question?
I hope I'm audible.
Yeah, now it's better.
So I wanted to ask you regarding a general question about these complex systems which you are talking about today. That is, this is the age of learning by examples. That is, most of the world's applications are moving towards learning from examples presented to a system. So from modeling point of view, how are we moving towards this? And maybe from mathematical point of view, like how are we moving towards this? We are familiar with the rigorous mathematical modeling that you are expert of. So from that field, how is it looking towards learning by examples?
Yeah, well, first of all, realizing that what is the real example? It's just, we have thousands of paper on COVID-19 pandemic mathematical model. How many of those papers are going to the decision makers and making an impact in the society? Why it is not happening is because those are theoretical model. They are not directly thought of from a data perspective. It should be guided by the data itself. That's a key issue in the mathematical modeling community, first of all. Okay. Second of all, there are lots of things that we are realizing. For example, we are realizing statistical inference. We do a simple parameter estimation, right?
Yes.
It's a big issues what the statistical inference is about observed distributions in the field. And
Yes.
that is an unknown quantity. So you need to do a massive study in order to get a handle on what is the observation errors look like, for example. And we spend fraction of time in doing statistical inference as compared to uniqueness and existence of the mathematical model, which is okay, but not every time the same thing, right? In all the study, which makes no sense to me. Some of these techniques mathematically were proven 60 years ago. With Lipschitz conditions satisfied, you could use those ones in our study. I mean, without any proof. Basically.
Yes.
Another aspect which is we are less doing is something called as validation with this. Once we get the outcomes, how do we validate in a real life that this is the data? There are lots of mathematical tools to validate, but we are less using. That's the areas that we need to enhance our study.
Thank you, sir.
Thank you, sir. Due to lack of time, sir, one last question posed by my student. So, as trend of startups is booming in India right now, is it possible to convert research on math models to a startup? So, from math modeling, that research can that be looked as a startup? Sir? Can that be led to a startup?
Well, industry means models, mathematical models. Industry means that, because no matter which field you take, they are building model. No, finance, they are building model. Mathematical models. And now mathematical, when I say, it doesn't have to be only differential equation based. It could be a different type. You have to be learning different types of models, not as once. It's like I have a hammer and I use everywhere I see that hammer, I want to use it. It should be variety of models, and the problem should guide you which models to use actually. So finances use it, healthcare is using it. Everywhere we are using, they are using Markov model, they are using deterministic dynamical system based model, they are using delay models, simulation models, time series models. Everywhere, all fields are using it. So I think when we say mathematical model use, I'm not sure exactly what you mean. You see?
Okay, sir, due to lack of time, maybe we have to end the
Sure.
session. We will continue our discussion further.
Fantastic.
Thank you, sir, once again for this wonderful session. We'll end this session, sir. Thank you.
Thank you very much for having me.